Today's connected businesses have to be more efficient in order to be profitable. Could you imagine not having a cell phone? Or not being able to quickly search the internet for answers to complex problems? Or ordering anything you need with just a few mouse clicks? Where would we be without the speed of text messaging? Or how would we be able to stay in touch with mom without the convenience of social media? It can be like that for your business too. The Internet of Things, or IoT, helps connect sensor data from data anywhere in the world to state-of-the-art analytics that provide you with the information you need in order to make decisions that benefit your operation. Unlock the power of IoT for your business and manufacturing process using Sorba, the world's leading enterprise platform for IoT. Use Sorba to collect data from devices in a secure and reliable way. Integrate your devices with the enterprise. Perform real-time big data analytics and machine learning analysis. Launch new products and services. Reduce deployment time, cost, and risk. So, how can Sorba help? Integrate your devices, processes, and services using our Sorba API. Sorba SDC collects data and is fully integrated with industrial communications protocols that talk to your machines. The Sorba Big Data Platform has the power to manage and control millions of connected devices. Sorba Historian can store as much data as you need. Sorba Analytics can derive valuable information. Sorba Machine Learning can predict and prevent failures, improves efficiency, keeps people safe, protects the environment, and diagnoses your systems. It's like having your own personal doctor for your business. Make your machines smarter by running our machine learning algorithms in your PLCs. Sorba Advanced Control can help. Use Sorba Remote Access to connect your devices from anywhere in the world and save money, and avoid downtime as a result of having to do on-site troubleshooting. You will get peace of mind knowing Sorba is hard at work alerting and sending alarms when things go wrong. It's like having smart virtual operators working 24/7 who never take a coffee break. Sorba connects factory data and enterprise to improve efficiency and become more competitive, building smart connected products that talk to each other and back to you in real time. Take the knowledge you learn from one system and share it with others. Build communities of smart, intelligent machines that maximize efficiency and profit. Take a test drive today and let Sorba put your device data to work. It is the competitive advantage that will make the difference. Work with us to make your enterprise IoT ready.
Hello, everyone. Thank you for joining today's session. My name is AJ Alexander, co-founder and CRO of Sorba AI. We're an enterprise software company focused on making machines smart and helping customers through the democratization of AI machine learning. So really empowering users that don't have a data science background or coding background to build and deploy these solutions at scale. So a little bit about us. We've been doing this for a long time. Our whole team's got over like 100 years in factory automation, control background, how Sorba was conceived, and what the problem we were also trying to help the industry solve was this, all the cutting edge technology academia is working on versus the emerging technology and the trends and solutions versus the gap in terms of how industry is taking advantage of some of the cutting edge solutions that it's been around for a long time, but allowing it to come on the scene pretty explosively due to the increase in computing, the accessibility, due to the open source community. So now a lot of these solutions at an enterprise level, where you're power generation, manufacturing, transportation, or utility focused, it's now taking this concept of web services and deploying it in very legacy or brownfield environments, and doing this at scale. That's very important theme of today's session. Biggest problem, another one of the biggest problems in the industry really due to the true adoption and total cost of ownership associated with AI machine learning and adopting it and implementing it to improve energy efficiencies and to be a much more sustainable producer of goods in the global economy. So understanding that we feel that if this is going to be our goal to democratize and to make this kind of technology ubiquitous, we want to put it in the hands of the subject matter expert and that domain expert that if they only had access to this tool, they'd be the best candidate to take full ownership of these kind of solutions, and then generating some of these global and agnostic energy reduction KPIs, whether it's kilowatts or fuel related, across any of your combustion assets, and agnostic to essentially any control processor or asset, whether you're discrete, your continuous process, or your batch. There is no constraints there for Sorba AI. So there's another big emphasis and theme around being production ready, being operational. How do we have better, more efficient, explainable AI? How do we decompose the black box to gray to white? So it all starts with the source and the machine. What does the ETL look like? Can we automate all the steps in the connecting, collection, the processing steps in your journey when it comes to using AI to reduce energy? And a lot of this being done at the edge. And that's one thing we take pride in as a company, is we are an edge, a fog, or we can be a hybrid with the edge and the cloud. How Sorba is commissioned, hosted, deployed. There is no constraints to who your cloud services provider. And then if there are, and you have a strict regulatory requirements like NERC and FERC, especially in power, we can actually commission this on a machine as small as the one you're probably watching this session on, or as small as a Raspberry Pi. So all that computing being done at the edge in real time to better control your equipment to generate whatever that optimization objective is. Going to the next step in these flows this is really just kind of walking you through some of the mechanics, right, on how the user would use Sorba AI, and then really focusing that this decision making is being done next to the equipment, whether you're on the automation side of your network or on the DMZ side. So we talk about this is a platform. We are an operating system where you are running Windows license maybe on your computer, and you've got Excel and Word and OneNote and all these great applications. Same concept when it comes to our platform, where users are doing it for energy, or they're wanting to improve OEE, or they're trying to get much more advanced on their existing condition-based monitoring strategies. We're definitely seeing the payback, or seeing the the value and how this gets operationalized in real time is translating into significant dollars per site or per asset in terms of savings. As you guys are thinking through this logically as a decision maker, a lot of times maybe energy and fluids or anything around sustainability is usually prioritized last, where now a lot of executives are understanding the payback can be achieved much faster with a lot less overhead, generating much greater dividends over the course of three to 5 years. And where Sorba sits uniquely is obviously it's very attractive from a no-brainer, an ability to quickly validate what is the value in the data. And if we were to have this model in production, what would this look like for the business? So great returns, in addition to having what we call the franchisee handbook, the O&M manual, the McDonald's manual for organizations to take this template, how to train their teams here, from the install to the application, to some of the configuration of both the edge, how to collect data, how to model the data, how to deploy your model, how to retrain your model, how to actually take these data science scores that are being automated and generated for the user, how to put it in the context and the nomenclature of your production process. And then lastly, the theme of scale. Can I, now that I have a working energy reduction model for kilowatts and compressors, can I take this to more compressors, to more sites, right? Even if it is, of different OEM, and the understanding that there's going to be some massaging required. So turnkey solutions in a short amount of times, not requiring the overhead that you've either been exposed to or have been maybe burned on in the past. Going through the Digital Transformation University, very important. You have a partner that can expose the black box through documentation, technical workshops, tutorial videos, so exposing the schema of what, how, and why AI and machine learning can generate tremendous value to the organization. Always really important to note that you want to have good first principles, so depending on where you are in the journey or how advanced you are in the supply chain, a lot of your time scale and your decision makings when using AI to improve energy can be done on any of these levels. So whether you want to start small or you want to start at the enterprise level, it can definitely be done. Just depends on how you manage expectations and how you set success. And then focusing on the fact that we want to become more efficient with root cause analysis and being much more data driven as opposed to model driven on using these techniques made available to the industry to ultimately become and to explain our results and in terms of production and the improvement to production and energy much more efficiently. There's definitely something I feel the industry doesn't pay attention to is when you are trying to build this or you're trying to buy this, you really want to understand the importance of the edge in terms of the data source that represents your energy problem, consumption problem, versus the actual engine, the black box, that's going to generate the improvements and the process improvements that you need in real time. So the steps between the two buckets need to be reliable in terms of how the data is collected, processed, transmitted, secured. So having all your firewall rules in place, in addition to the feed forward technology, and in addition to the payloads of that data, you want to be efficient, and you definitely also want to keep into consideration the cost of your data science or data center storage cost, in addition to the bandwidth or whatever cellular WAN schemas you guys have set up. So really important that your solution gives you access to connectors and to protocols that allow you to get data from any sensor, any of your level 2, level 3 systems or your enterprise systems, automatically automating all those entire ETL functions. Grounded truth is really important in terms of what does our life look like today without AI and machine learning, and do we have that understanding of what is normal, both logically and mathematically. Very important that everyone understands the process and the problem as a team from a steering committee, and then you can you'll have a greater respect or appreciation for the insights AI can derive for you. And we always want to keep into consideration, if our focus is to empower SMEs and to empower the domain expert, we want to make sure that their constraints are also built in or else defined prior to the modeling process. And a lot of the steps that are being automated for the user are around, your principal component analysis, your dimensionality reduction, the p-value techniques, how you ensemble that, how you post-process, and be able to nicely see the interpretation of your model after it's done training on the data. And then to understand that you are generating, from an energy reduction point of view, you are able to generate optimized process parameters and thresholds, and you're actually able to reinforce a smarter dynamic set point that if you're trying to reduce energy, that's ultimately your goal, is to whatever's happening in real time with that set point, where you set your system to versus how it's behaving mechanically, the PV being read and measured. What's the difference between the two? The error, and be able to calculate that and reduce the oscillation and overshooting in your control process is essentially our goal, and how customers are using Sorbet AI to reduce energy. And basically taking this information, bypassing the PID in your control layer, or making it that much more intelligent. Always want to be able to quickly identify what is our optimization goal here. Do we have enough equipment and instrumentation in place? And then what is my independent variable? So if you control these valves or these particular data points, you're actually going to cause your system to consume more energy than you originally intended. So you don't want to do that. So this is also very important steps that we go through from a framework perspective. And then lastly, what can I control, what I cannot control, and what I can control. And then going through the black box where I'll show you what this configuration process will look like. But after you logically define that, you'll go through some of these steps. And then what is a digital twin means a lot of things to a lot of people, but it's essentially for us, what it means is essentially a neuron or neural networks of these multi-regressions generating all of these predicted outputs being fed into one another to achieve a much more optimal and much smarter decision when it comes to control. And then knowing that you have access to a digital twin pipeline can actually allow you to maybe do better simulation efforts, or allow you to clean the data better, or allow you to test good models you have running in production versus different events, different step changes in your process, different data that represents different scenarios, that if you had this sensitivity or an ability to study this much more frequently, who knows how much better your control, your AI control could be with the goal of reducing energy. Lastly, we want to also take into consideration us being able to be ethical and transparent, and to know that if for whatever reason our AI APC is not behaving correctly, from an author or a source code perspective, you should have the heartbeats, your watchdogs in place to make sure that for whatever reason, AI is always going to be abiding within the constraints you tell it to abide in. So very, very important. And as you're going down the journey, we always want to think about the less noise. The more we can show value on smaller data sets with the less noise, then we can think of this as almost like a version 0.01 concept, where you are letting the algorithm learn and become, you're rewarding it, and you're allowing him to mature and grow over time. And the p-value for us, especially when it comes to reducing energy, is what are the data points or tags that have the highest contribution to a failure, or have the highest relationship to one another in terms of, if you're trying to get more efficient with energy, you should really focus on this subset of data points. So it's going to allow you to eliminate your noise really, really quickly. And a lot of the interpretation of Sorba, which will show you what this process will look like closed loop in real time, will always be able to tell you in the data what your room for improvement is based on how you're controlling equipment today. And that is essentially that simple, where these data science techniques and these scores that are traditionally scripted or have to be scripted by hand or manually is being generated for the industry automatically. So you can see here in the blue, Sorba is saying if you were to stay within these constraints and using this set point, we would have reduced all these events in time. And I don't know what these engineering units represent, but these are my optimal upper and lower limit bounds. And then I've got a set point in here that's my chimney set point is always staying within these bounds, generating that 7% savings or that 7% reduction. These are all of your non-optimal states and points in time, and eliminating that is where we're going to start to see the biggest economies of scale take place. And when you look at this, your processes, which is obviously multi-dimensional, I'm showing you things non-linear on a non-linear basis, but with life with APC enabled, as you can see, your fuel consumption is much more ideal, as opposed to it being disabled and not being ideal. Now we want to be able to map all of this decision making, all this configuration to your process in real time. And what would this look like if you were driving? We'll show you that in a little bit. And some things to keep into consideration around doing this for quite some time, and seeing where customers struggle most is around the data integration, massaging the data, having enough data, maybe not having the right person for the process seated at the table, asking the right questions, and then not trusting AI and not having good validation techniques or tools and steps in place to scale these solutions. So now what I'm going to share with you guys is what this journey would look like if you were to be driving. So everything starts with the edge. Like we mentioned, we are a hybrid company where we have no constraints on computing. This is the edge, where you are going to define your data pipelines, your edge that we talked about. So in your channel, you're going to come here and you're going to have access to any of the drivers, whether you're talking to your process historian, your PLC, some of your data servers, or you're wanting to get weather data, you're wanting to talk to your building automation systems. There are no constraints, and there's never been something that Sorba cannot talk to for AI, machine learning, and analytical applications to be built. And then on the edge, we're not going to talk about these other features. We're going to quickly get into how you guys would model your process. Here, your data, once you import into the platform, Sorba will automatically calculate and generate some of these techniques for you. But now it's come down to creating a project. So what we're going to do is we're going to call this Energy 4.0. Here's what I call the app store that you guys would have access to create your model. Once your data is done being imported into the platform, so I'll come here, create an analysis. Here are all of my data points or my tags that represent my process that I'm trying to be more efficient and be more sustainable on. If I want to add constraints, I can, but I don't want to. I'm going to select next. Now this is where we have access to your pipelines that we were talking about. So these two are typically used for your asset health applications, which I'll show you in a jiffy. Regression and digital twins, you're trying to generate what is that error score within my process. and then lastly optimize. And I actually want to be able to reinforce that decision in real time. And then forecasting, you want to be able to, maybe optimize different MES KPIs or anticipate different things upstream or downstream to make your actual volume and performance that much more better. And if you do, and what's cool about Sorba and what we feel is a cutting edge and really an emerging technology industry is, for us and our users, you don't need to know any of these techniques. They're done automatically for you. But if you do, you can select them. If you don't, which majority of our users do, you let auto select, and Sorba will select for you based on the data, variety, volume, velocity, and there's another V I'm not remembering, but it'll do it for you. It'll select it for you. But optimization, this is specifically used for energy reduction. I would select what I want to reduce, fuel flow, minimize it, select my independent variable. We talked about how you define that, et cetera, et cetera. Select next, select next. Once this model is done training, then once you map it back to the algorithm, your optimization model will look something very similar to this. Oops, right here, boom. So now I have my boiler represented. My APC, my advanced process control algorithm is not enabled, but I want to enable him. So let's enable him. Let's see, and then you can see I'm not doing very good in terms of my fuel consumption, but let's give it a chance to optimize. Hit the refresh rate, so you kind of see here on a time scale, my process just went up a little bit. You can start to see the monies are starting to be gained and summed, and all of my those dynamic set points I was mentioning to you are staying within these optimal bounds, with the goal of reducing fuel and generating enough steam and power for the rest of the facility. So this is something that can definitely be done without writing any code. That is being done by lots of our users around the world. And we're just really excited and really fortunate to share this with you, and look forward to talking about how Sorba AI can help you along your energy reduction and energy digital transformation journey. Thank you.